What I'm just going to do is tell a little bit about what the AECB has been up to fairly quickly, and then describe a bit about where our head is at. How are we thinking about things? Right, so a little bit about the membership. We seem to be seeing an increase, which is good. 25% increase in members over this year. We have members from every sort of corner of the industry, and many of those members are people who've been pioneering for years and deploying and leading on best practice. So it's a very well-rounded membership. Building standards, I'm sure you're familiar with. There's the new build standard, self-certification, 2 retrofit standards now. We've got the original one, which we're calling level 2. We've got a new one, which is a heat pump-based light retrofit standard, which I'll just touch on, which we've been doing a lot of sort of research into to make sure it's a viable standard. We have a water standard, as you know, and then the lifetime carbon standard and the daylight standard are not actually certifiable standards as such. So we're going to be developing training to help people understand and deploy all of these standards in the next year. So that's where the direction of travel for training is. So this new level 1 retrofit standard is based on the fact that we do recognise, so we've challenged ourselves on the deep retrofit agenda. Deep retrofit is a very meaningful, useful thing to be doing, but it's not the only thing we should be doing. So we clearly need to get off fossil fuels rapidly. Heating by electric heat pumps offers an easy and potentially cheap route when combined with relatively light fabric retrofit. So it's not an intrusive approach, which a deeper retrofit obviously is, and that's what we're struggling with. We do require good ventilation to be installed as part of that, and obviously we have an eye on the running costs after the retrofit, so we're trying to pay a lot of attention to the reality of the performance gap and make sure that after such a level 1 retrofit, heating costs are not higher than the fossil fuel system you've come off, so we're doing some economic modelling on that. We're not discounting going on to level 2, so level 1 is either a step towards a deeper retrofit, level 2, or those buildings at level 1 may well be sitting there operating on that level for years, 10, 20 years. And so we've been looking at what happens if we have 2 waves of retrofit, a level 1 and a level 2 over time, and you'll illustrate this in a minute. Is that still a meaningful thing to do? Because one of the things we've been worried about in the past is people doing shallow retrofits which lock out future improvements. So the standard we've developed is designed to not block that second, deeper retrofit. So it's thinking ahead on a long-term plan. So just to give you it's a overly complicated graph, but what it shows is the existing housing stock. And obviously what we need to do is to get that entire housing stock and shift it over here to reduce the space heat demand. So when you're thinking about reducing the need for heating, we have aspirational standards like Enefit, which will apply to a relatively small number of homes perhaps. I live in one, and it's very, very comfortable and very low energy. Very happy I did that. The level 2 retrofit standard is less demanding, but still a meaningfully and useful standard here, which you set at 50. Now, there are exemptions within the AECB level 2 for listed buildings or other very good reasons which we set out. So potentially, a certified level 2 retrofit could be demanding 100 kilowatt hours per square metre. So it's actually a range. Now, I've put a note here that space heat demand is not the same as delivered heating energy, which is what you pay your bills on. So with the level 1 retrofit, there isn't a space heat demand target. What we're doing is making sure that there are just enough retrofit measures and ventilation measures to ensure a relatively healthy building, but we're using a well-installed heat pump system. We're using the efficiency, the very impressive efficiency of heat pumps to, in effect, reduce the heat demand through 350% well-installed heating systems. So this is the criteria by which you would certify to a level 1 retrofit. So I've just picked out the sort of key features here. What we're doing is changing the heating system from a fossil fuel system or direct electric heating to a heat pump. We're thinking about forward planning, so we need a long-term energy plan, and that currently is using PHPP. The heat pump system, we're looking for that efficient installation. So we're talking about the relationship of the heat pump with the radiator, the heat emitters, the underfloor heating, or the radiator sizes. And if we can get that right, and what we thought is the best criteria is actually setting the flow temperature for the heat pump designer to actually be low enough to get those efficiencies that we need to keep the running costs under control. So that's one of the criteria, flow temperatures less than 45 degrees. Controls is an important area we're still doing work in, but that probably will turn into some sort of criteria. And air tightness, feedback from members about what is possible whilst not going deep into a building. What can you do from outside? You know, if your existing homes are around about, well, I mean, they could be already our target. Existing homes could be at 5, but typically they might be at 6, 7, 8, 9, 10, even 13 or more. So this is an important criteria, and we've set it at 5, whereas the level 2 retrofit is 2, passive house new build is 0.6, and EnerFit is 1. So it seems like a doable and reasonable target, still stretching, and this is permeability. We must have ventilation, so we're putting in sort of optional requirement to show that you've put in adequate ventilation to maintain good air quality, and of course there's an overheating criteria down here. So what I'm just going to show here is the background work we're doing to try to make sure that what we're suggesting is sensible, both in terms of individual homes and also what happens if it is scaled up, if it is ever scaled up. So the models we're using are Passive House Planning Package for modelling case studies or archetypes. So a typical semi-detached house, is that cavity walled, is that solid walled, a bungalow, a mid-terrace townhouse, and so on. So generally we're working with 3 house types which represent different form factors. So the basic geometry makes retrofit quite challenging. So we've got a sort of high form factor, a medium and a low form factor house type. And each of those will have either a cavity wall in place with insulation in place or solid wall. So we're looking at the extremes and trying to understand, does this standard fit a range of house types? And then we've also tried to look at, if you add all of that up and you look at the English housing stock, what does that look like in terms of CO2 emissions? So we're well aware that the modelling we're showing is not saying this is what will happen, this will be the 1 million tonnes per year of emissions as a result of applying our standards. We're asking questions and trying to dig deep into how it works at scale and understand the issues of not only operation energy, emissions related to heating and powering a building, but also manufacturing the materials. So here are the 3 typical house types we've used, and then we've chosen the cavity-walled, semi-detached house as the kind of easiest one that is most typical of housing across the UK. So it's actually a very useful house type to try to illustrate what a level 1 standard might look like. So for example, we talked about airtightness, so the semi-detached house you'd aim to get down below 5. We assume 50 mil of cavity wall insulation in place. If it's not in place, then it would have to be put in place. So there is a fabric measure there, but we're assuming this is a starting point, that there'll be some relatively poor cavity wall insulation in place, that there'll be some double glazed UPVC plastic windows. Again, if they're single glazed windows, not many houses now have those, but that would also be another measure you would need to employ for level 1. And then basically on goes the heat pump. So that's a sort of package, with a topping up attic insulation to around 400 millimetres, so that might require some attic top-up. So you can see it's a potentially a lightweight, sort of light retrofit. So we're not insulating floors there. And so the sort of key things we're looking for from the people who model using PHPP, you will get an increase in internal temperature, average internal temperature. You will be looking to make sure that the running costs, the electricity running costs, are no more than the gas or oil that you've come off, so you need to keep your eye on that. And of course, we're looking at this very significant reduction in greenhouse gas emissions because you're going off gas onto electricity, the national grid is decarbonising, and these issues that we have been fretting about, how much electricity is going to be available to shunt 80% of homes from gas to electricity. Can the grid cope with that? Well, it won't be able to cope with that without increasing the capacity. But at the moment, for the next 5, 10 years, we can get on with this. So there is an issue of peak heat demand, but we're not letting it get in the way of proposing we get on with this type of retrofit. We have to make some assumptions about the rate of decarbonisation of heating energy. We've built that into the model. We have to make some assumptions about manufacturing energy. We are assuming that over time, manufacturing energy will be being decarbonised, whether it's use of hydrogen or electric arc furnaces for steel making and so on. Now, David's report looks at some of these aspects. So these are assumptions, and these have big effects on what happens. This is the proposed decarbonisation of the grid, and we're sort of tracking what it actually looks like. So you can see there is a discrepancy between the aspirations coming from national grid modelling and the actual reality, so we need to factor that in. This is the shape of what a retrofit programme might look like under this scenario. So a level 2 retrofit gives other than non-energy benefits. It gives some very good non-energy co-benefits warmer, healthier, further isolating people from energy fuel bill shocks. And so we imagine, social housing is a very good example of where level 2 would be something they want to aspire to straight away, whereas maybe able to pay market would be going for a level 1, this lighter retrofit. Now, over time, maybe the national grid is creaking, and maybe we then need to convert some of these level 1s to level 2s. So it's just this concept of 2 ways of retrofit, I think, is what this graph is showing. And we can change the proportions of a level 1, level 2 over time and start to ask questions about what that looks like. This just is flicking between if you decarbonise manufacturing and if you don't decarbonise manufacturing. So you can see that if we don't decarbonise materials, it does have quite a significant effect on CO2 emissions. That's just showing how the mix of the dwelling stock would change under these different scenarios. So that's the existing housing stock, and we change the mix, level 1s, level 2s, and we're adding new housing, of course. So in this scenario, we said from somewhere around this point here, we really should be building AECB standard new homes or passive house homes. And there's a big debate about how many new homes we should be building or can afford ecologically to be building. And then this is basically summarised in the stock model by looking at, do we get these scale and speed of CO2 reductions from space heating from our housing stock? This is just space heating. So down here you've got the embodied carbon emissions from the materials and heat pumps that you put into the structure, and this is the actual space heating CO2 emissions. So this is if we decarbonise manufacturing, this is if we don't. So you can see actually that there's actually quite a significant effect here, carbon emissions from manufacturing, which does cause us a little bit of an issue if we're trying to hit this trajectory. This is what we need, according to Paris, something like this. And then that's the cumulative. This is what drives climate change, cumulative CO2 in the atmosphere, in this case from England's space heating emissions. So you can see that without decarbonising materials, we are struggling more than we are here. What we want to do is get that flat. We don't want to be adding any more. In this scenario, we're not. It's still increasing there. But we're trying to be fairly realistic and not get lost in fantasy lands of carbon-sucking machinery and so on. We're anticipating, we don't know what we're anticipating, but we're seeing the effects of climate change now. We're seeing this speeding up of effects, particularly up in the Arctic areas. So we're designing buildings that last well into this period where we'll be experiencing something like this. So obviously we cannot stop. We have to continue to try and dramatically cut our emissions. We've just been talking about that. We have to focus as well on resource efficiency. So we end up with this sort of list of basic principles. If we don't need to build, or we can find another way to satisfy the client's brief that actually doesn't involve building, don't build. That's a very sensible approach. If we do have to build, look for opportunities to retrofit first to satisfy the brief. If we do build or retrofit, don't make it too big. That's sufficiency, modesty. That's quite hard to sell to clients, but we do have to be thinking about that. Obvious things like making it adaptable, make the individual components last a long time. If we're using a lot of timber components, we don't want that coming back into the atmosphere sooner. It's later rather than sooner. I really want to encourage all of you who are not working to the AECB standards to actually just start working to the AECB standards and get them certified. It really gives a clarity, whether it's a passive house, NFIT, AECB new build, or the 2 retrofit standards. Working to a standard and self-certifying it on the system gives a real clarity. It also helps with clients. Once the client has agreed to work to a standard, it gives you a much stronger hand when they're making changes, last-minute changes. It's basically, no, it's falling out of the standard. Right, so when you go around the conference, you'll see there's a couple of AECB assemblies where we've set a challenge, which is basically building 2 areas of difficulty for retrofit. It tends to be towards the bottom of a building where there are issues of moisture and ground and concrete slabs and all that sort of expensive stuff. It tends to get a little bit easier once you're out of the ground. So we concentrated on a suspended timber floor that you might find in a 1930s, 1940s cavity-walled house. So that's what might be a lighter retrofit with a heat pump, where you might be looking for how do you apply air tightness measures to floor perimeters. If you have an opportunity to insulate suspended floor, you might choose to do that at this stage. You would expect cavity wall insulation to be in there anyway. So that throws up various building physics issues to do with air tightness and moisture and DPC. So Those are the things you can look at and explore with ecological building systems in this particular instance. So we built that from offcuts of CLT. This is the key. So basically, if you just look for these keys, this is showing the sort of materials that you might find within these buildings that you have to think about. Ventilation features is a good example. And then this is the deeper retrofit based on a real project. Carbon accounting in buildings is time-consuming, but it is also very insightful. So I don't think we imagine that every architect or designer will be doing one for every project, but we assume they'll be doing it and building up ways of building lower carbon construction assemblies, building up a sort of in-house library. World War II bomb-making factory seemed very appropriate. A little kind of rather maudlin kind of thing down here, we can do it, but can they? Thank you.